Well, good afternoon. Finally got the part for the E4406A delivered from Italy. So let's open it up. Let's take a look. Here you can see it came from RF Microwave out of Italy. I don't remember exactly where in Italy they were located. Senago, Italy. Anyway, we've got the component now, so let's drop on my grounding strap and open up the packet here and make sure that we actually got what we were looking for. Okay. Oh, and that looks fantastic in there. Okay, let's put that out of the way. We'll check the thing, make sure it is exactly what I ordered. It doesn't tell me, it just says the order, what the part numbers were. So let's take a bit of a look. Oh yeah, they're a real part. So let's let me zoom in and let's take a quick look at that. And so what you can see here is their information, and the Hewlett Packard part was this. But if we open this up, either somebody's gone to an awful lot of trouble for this, or this is exactly what one would expect to see a part. Look at it, it's nicely packaged in there. And then on the back here we can see the the Hewlett Packard information. Don't open except at approved field force protective workstations. So I'm guessing this must have been spare military parts or something at some point. We don't have, interestingly, let me grab the other one and let's put this in here. And you can see the other one has, let me zoom right in so we can get in, and this will macro resolve just in a moment. There we go. And so we can see that this one has a part number 1GG74218. On the schematic, it was listed as that part number or a different part number. But over here, you can see that. Let me pick this guy up. You can see that they're very similar parts. The leads are a little longer on this guy than they are on here, and there's no little screen print on top of there. So anyway, let's get this set up. Anyway, we'll get this set up and we'll see how it looks putting it on the actual PCB. Okay, so here's U38, and so now what I want to do is I just want to test fit this just to see if this is actually going to fit on those pads. So let's just drop that in there. And then let's just line it up. Yeah, I think that going quite nicely. So now it's a matter of me making sure that it's orientated correctly, and then we'll solder that on. Alright, let me go get that. Now I bought two of them because you never know, one might be dead, or two, I might screw one up. So alright, now we'll go and get ready to solder that on. Alright, so now we need to make certain that the actual component lays down on the pad here in the correct layout. So this is the particular view of this board, and so you know, if you look over here, this is U38 and this is U38 here, and then next to it has U26 and this is U26 here, and then you can see there are a couple of little components around it that are these guys around here. Now, they don't actually mark a pin 0 on here in a traditional way that a lot of people are familiar with. What they've got instead is this little square here, and it's easy to miss, so let me zoom right in. This little tab right here on the lead is going to tell us where pin pin 1 is. Now, see if I can grab my tweezers, drop them on the floor, I'll need those in a moment. If we take a look at the data sheet over here, you'll see that pin 1 is marked with a little bump on it as well. And if we come back and have a look at the actual component itself, and let me see if I can get that in view. Is it gonna? No, how? Let's actually zoom right in, and we'll get the macro lens working. And then up here, you can barely see it, but there's actually a little tab on the end. So now we know the orientation of this device, which is going to go like that. Going to go like that, so that that little tab that we can see just right there is going to align with that spot on the board, because it aligns with that little tab there. Now we can, let me zoom back out a little bit. We can more or less confirm that by looking at the actual schematic for the item. And here you can see that we're going to have ground being brought in, or controls being brought into 3 and 1 here. And then we're going to have RF in on 5 and 8, and then we're going to have 4, 6, and 7 be ground. And so if we take a look at the package here and have a look at how this is laid out, 1 is a control, 3 is a control, 2 is the RF in, 4 is a ground, 8 is out, 5 is out, and 7 and 6 are ground. So if we look again back here, we saw 7 and 6 being ground here. And if we come over here and look at the actual, let me take that and let's zoom that again back in a fair bit. If we were to look at these 2 pins just here, you'll notice that they're actually connected to the ground plane. So that's telling us that that's going to be 6 and 7, which means that's pin 1 over there. So now that we know which order the pins are going to go in, what I want to be able to do is to get my chip quick solder paste, and we'll actually lay down some solder paste here on the items here, and then we'll use my hot air gun to go and solder that down. So let me go do that, and then we'll see it all completed just in a moment. Alright, so we're soldered down now, so let's get in and remove the leftover flux. Let me get my light out of the way here a bit. Okay, so we put flux remover on, give it a little scrub with the horsehair brush. Okay, a little bit more. There's the hot air tool is now just cooled down and turned off. Okay, so now we drop in some of the cleaner, the superwash they call it, which is a rinsing agent. And so we can just rinse that off, and then we should just be able to pat that dry. And there we go, more or less. Okay, so you can see the component is now in. So I've taken a look at the legs, and they all seem to be glued down. I think next time I do this, what you should do, what I should have done is make sure those legs were bent down a little bit, because when I started gluing it, when I started soldering it down, some of the legs were floating a little bit, so I had to push them down, which made it not quite the cleanest surface mount job. But that still does, it looks like it should do the job. So let's get this back in its case, and we'll plug it in and give it a try. All right, be back soon. Well, good morning. I managed to get the second of the little integrated circuits in, little relays in last night. I put the first one in, and it didn't work, but I bought two of them, so I put the second one in, but I didn't get a chance to check it. Now, I've looked at the solder joints. They're all well done there, so let's cross our fingers and boot this up and see if it works. So I find it hard to believe that I've managed to get two failed relays in original packaging. So hopefully this will work. Yeah, so we can see it's booting up. The camera's having a little trouble focusing on this. Fortunately, it's not. You can see the. Let's zoom it back out a bit and just make sure. So this, I think, is because I lost the battery on the CPU board is that, but I have a spare that we'll put in if this fixes the relay. Okay, now we're getting our diagnostics check. We can see the signal down here. Now this will be our first one. Does the gain curve work? No. Alright, so that's exactly the same problem that I was having with the original part. That's the same problem I had with the first part I put in. It's the same problem I had here. So there has to be something else. I can't believe that I got both of those parts broken. So let's take a little bit of a deeper look and see what is actually going on. This is a attenuator is going to fail because it's not getting the cal signal through to be able to check that the attenuator steps are accurate. So, alright, let's set up and take a look and see what is happening actually on the circuit itself. Okay. So this is the circuit, and this is what we've looked at before. This is the first converter, and our RF signal's coming in, and this is the microwave relay that we just changed, And that comes off into the attenuator that then goes off into the mixer. And you can see that there's this 50 megahertz cal signal that gets fetched in, and then based on the control of cal switch A or cal switch B, it switches back and forwards. Now, it does that, let me see if I can find, based on these control pins here, and it does it with a little truth table, and basically if the control voltage is 0 volts and the other voltage is -5, then the one with -5 is turned on, and if you flip that around, then the other one is turned on. Now, they have this switched around, so this data sheet refers to basically an RF in going to 2 outs, but they're actually using it as 2 ins coming into 1 out. That doesn't matter, just feeding it in a different direction. So if we look a little closer at the cal control, what we'll see here is that cal switch comes in. Now, this is going to be a TTL signal, 0 to 5 volts or thereabouts, and that's going to come into this dual op amp here. And you can see that dual op amp is fed with a plus and minus 10 volt rail. Now, with the iron law of op amps, where they will drive this output to whatever voltage needs to get the two inputs to equal. What I should see is, as those inputs come in, and they will be different, this should drive to the rails, either the plus 10 rail or the minus 10 rail. Now, it's not going to be quiet, because this isn't a rail-to-rail op amp, so it's going to be some value up and some value down. But it's going to be around, -8, -10, -9, +8, +9 there. Now, that value comes in here, and this forms a little voltage divider, and this is this will come in and be about a third, so you're looking somewhere around 2.5 to 3 volts of whatever the thing is. If we go stick that into the calculator, that's going to come out and give me, according to the calculation here, is a 2.23 value. Let me make sure I got that right. I just cancelled it. Okay, what is it? It's a 6190. Cancel, cancel, cancel. All right, let's try this again. All right, so 6190 divided by bracket 6190 plus 21500, close the bracket, equals 2.235. So as long as I get something around 2.235 when I measure either pin 2 here, pin 3 here, sorry, or pin 2 here, or the test point, everything should be kosher. Now, interestingly, I don't know if I printed this out on the switch is designed for -5 volts control, and it says that the absolute maximum voltage is -8. Now, this could be the problem here, because if you look at this circuit, this is going to give you -8, -9 volts, depending upon what this op amp's doing, and plus 8, 9 volts. So it's going to be around or above the absolute maximum. So the only thing I can think of is that HP, because they built both the schematic here as well as the integrated circuit, that they spoke to the designers of it and said, can we save $50 by just using our existing plus or minus 10 rails, rather than putting in another -5 rail on the board, and then all the associated layout and cost and so on. And the designers probably said, sure, it'll work. I'm hoping that's what they said. I'm hoping they didn't say, oh, well, what we'll do is we'll go and pick versions of that, we'll make you 10,000 of them, check them and see if they work for the control voltages, then we'll bin them specially. So I may not actually be getting the right part, because it may be a special bin part. So, that could be a case as well. So what we'll end up doing, let me zoom back out, what we'll end up doing here is we'll eventually, if it's working inside, so I'm getting the right control voltages, then it should switch. And if it switches, if it is correct, then I think what I'm going to have to do is take it out. Well, I'll probably try the first one and actually hook it up on a breadboard, and we'll just see whether or not we get a switching at 0 and 5 volts. And we'll see how that goes. So let's get my meter here, and we'll turn this on. And let's see if I can drop that in so that you can see the voltage there. So now, you know, if I read, because this is connected to the ground plane, let me get my glasses on so I can see what I'm doing. So the control pins, again, were going to be pins 1 and 3. So let me get everything out of the road. So now if we look at pin 1, we're getting minus 9 volts there, and then pin 3 and plus 8.21. Alright, so we are getting signal there. So let me see if I can, let me just get on pin 1 here. Alright, now let's go to hang on, let me set a range. That's 6 volts. Oop. Alright, let me set that range and then go to system and then alignments. Oh, crap. Let's do this again. Alignments and then align now. So we're seeing the control voltages switch back and forwards properly. Alright. So I think that it's working correctly. Well, hang on, let me do that again, but this time let's get on pin 3. All right. Okay. Yep, so we're getting control voltages. They're not sagging. This thing should only draw 100 microamps, so it should be more than capable of being driven by U26, which is just here. So, you know, there is clearly something else going on. Okay, so it's a bit fiddly, but let me try and get pin 8 in here, and then pin 2. I will hold that down, and then now I'm going to do an align all. Okay, and we can see that with the wire in there, it gives me a success. And now when I go to the attenuator steps here, you'll see we're getting a signal. So it's able to now check the attenuator steps. And there you go. So we have a proper signal. And let's actually check. Let me bridge across because I have a 10 meg signal coming in. So let's set the frequency to 10 megs. And you'll see this very low signal, so let's do a marker. And we'll see it's like minus 60, so it's actually worse now than it was before I took the original part out. So let's bridge from 5 to 2. And there you go, now you're seeing 0.56, which is 0 dBm roughly. So, alright. So it looks like the bridging the relay working, the circuit works, so there's something wrong with the relay. I think we're going to have to check the actual, try one of these on a breadboard and see how that goes. Alright, well, I'm going to do that as part 4 of this check. So I will catch you again later. Hope you enjoyed this. Give it a thumbs up, depending on which screen I'm on. And tune in for the next one. Catch you later. Bye.